Hello everyone, this is Vikas. Hope you are doing well. Let's start this video with a question. What did actually change after transformer architecture that we call, like we use the name LLM in nowadays? So in the machine learning field, we already had RNN. So why do we need transformer architecture? And what problem did transformer architecture actually solve? So we'll talk about that. First, we'll see the differences between RNNs and transformer architecture. So what is RNN actually does? So in RNN what we have is we have the sequence, sentence sequence. We process each token, input token word step by step. So in RNN we have a hidden state, and when it processes the first token, the next token depends on the previous token and not on the whole sentence. So that is one limitation of the uh, RNN. In RNN actually uh, it does not hold the information of the previous words. It just collects the information in a hidden state, and it might not work for the long sentences. So to solve this problem, this LSTM module came, LSTM cell, which tries to hold the memory in the RNN. So in RNN, now for the long sentences, we can have the previous history in the form of in the LSTM cell. Now the major limitation with the RNN is their sequential length. Like we see process the sentences token by token. So it takes a lot of time, and also it is sequential. We cannot parallelize it. So that's where the LSTM solve this problem. LSTM have three major uh, good solutions or strength. First is it does not take sentence into sequence like one by. It takes whole sentence as a one. So that is one good thing. So we reduce the time. We can make it parallel. Second thing, which is a more major selling point of the RNN, is attention mechanism. In attention mechanism, what we do is we have some weights, or it's a unit actually, to compute the similarity score between each words. Like each word in the sentence, you calculate this attention score, or it's a unit we calculate along with all the other words in the sentence. So what actually happens is we get the relation between each words. So it's a kind of uh, uh, major strength compared to RNN, where it has to remember the relation between all the previous words. It is very easy here, as you know, like it's computing a similarity score between each word, so it knows which sentence in the sentence which word is more aligned with the one word, like this particular word. So that's how this attention mechanism is helpful. Next thing is the positional encoding. In the positional encoding, along with the, as you know, like in the RNN, we process the word sequence by sequence. So it knows which is the first word and the like which comes second. But in transformers, you don't have any sequence, so we need a positional encoding. So in positional encoding, we have some weight assigned to each of the words in the sentence that gives some information about its position in the sentence. So that is how we encode this information in the transformer architecture. So it makes uh, transformer architecture to learn these positions very effectively. Everyone knows that where this sentence belongs. So these are the major, I think, progress after LLM, and in the in the machine learning machine translation tasks. So this is it. I'll discuss more implementation details in the upcoming video. Thank you. Stay tuned.